Determine the volume of the solid that lies under the paraboloid z equals 16 minus x squared minus y squared and above the circle x squared plus y squared equals 4 in the xy plane. Let's first look at this graphically. In blue we have the graph of the paraboloid, and if we extend the circle x squared plus y squared equals 4 in the xy plane up to the surface of the paraboloid, we are looking for the volume that is inside the red cylinder and capped off by the paraboloid above the xy plane. So because the volume is inside a cylinder, or because the xy traces a circle, we will use polar coordinates to determine the volume. So going back to our work, looking at the notes below, the volume under the function f of x comma y above the region R is given by the double integral over the region R of f of x comma y differential a. But remember, when using polar coordinates, differential a is equal to r dr d theta. And of course, we also have to write the function f of x comma y as a function of r and theta. If we look down on the xy plane, we would see this view here, which is the xy trace, given by the equation x squared plus y squared equals 4. So we have a circle with a radius of 2. And this is the region R. Also notice the given function f of x comma y or z is equal to 16 minus x squared minus y squared, which we can write as 16 minus the quantity x squared plus y squared. And we know x squared plus y squared is equal to r squared, indicating we can write the function f as f of r comma theta as 16 minus r squared. And now we will set up the double integral. So the volume V is equal to the double integral over the region R of f of r comma theta, which is 16 minus r squared. And then we have r dr d theta, again because we're using polar coordinates. And now we need to determine the limits integration for r and theta, looking at the xy trace. Well, we know the radius r starts at 0 and goes out to 2. The limits integration for r are from 0 to 2. And then the limits for theta will be from 0 to 2 pi all the way around the circle. Let's go ahead and distribute the factor of r in the integrand function. Distributing r, we have 16r minus r cubed. And now we integrate with respect to r. Integrating 16r, we have 16 times r squared divided by 2, which simplifies to 8r squared. And then minus, integrating r cubed, we have r to the 4th divided by 4, or 1/4 r to the 4th. And now we determine big F of 2 minus big F of 0. Subbing in 2 for r, we have 8 times the square of 2 minus 1/4 times the 4th power of 2 minus, notice when r is 0, both terms would be 0. Simplifying here, 8 times 2 squared is 32, and then minus 1/4 times 2 to the 4th is equal to 4, giving us 28. So now we have the integral from 0 to 2 pi of 28 d theta. And now we integrate 28 with respect to theta, which gives 28 theta. And now we determine big F of 2 pi minus big F of 0, which gives us 28 times 2 pi minus 28 times 0. Simplifying, we have 56 pi cubic units for the volume of the paraboloid above the circle x squared plus y squared equals 4 in the xy plane. I hope you found this helpful.